Hello everyone, I am Srinivasulu PGT Physics. Welcome to my YouTube channel Sri E-Class Physics. Here I upload video lessons physics for classes 9th and 12th so that you can learn from home during lockdown period. I prepare my videos such that you can watch them and simultaneously take down notes. I also provide link for the notes in the video description so you can download them and prepare later for your exams. If you like my videos, please hit the like button and also give your feedback, suggestions in the comment section. So there is a room for improvement. Also subscribe to my channel and press the bell icon for more interesting video lessons. Thank you very much. Hello students, welcome to Sri E-Class Physics video lessons. Today I am going to take up the applications of the Gauss theorem. There are three applications. First application I am going to take up, that is electric field due to infinitely long straight wire. This is the application of the Gauss theorem. In the earlier classes, we have seen the Gauss theorem. All of you remember the statement of the Gauss theorem, I think so. Once again, I'd like to remind you the statement of the Gauss theorem, and I'd like to give the mathematical formula of the Gauss theorem. Okay, it states that the total electric flux through a closed surface enclosing a charge is equal to the 1 by epsilon 0 times of the magnitude of the charge enclosed. Let me write here the mathematical formula of this one, Gauss theorem statement, and then we'll go to the applications. Here, heading already I have written for your reference, that you see here application of the Gauss theorem. Here, application of the Gauss theorem, according to that one, you know that phi is equal to q by epsilon naught. I think you know very well this. Okay. Now, there is one more form which is equal to phi is equal to E bar dot ds bar, which is equal to EDS cos theta, which is equal to q by epsilon 0. This is the Gauss theorem expression in complete manner. You know, in this expression, mathematical expression, you know what it is. Phi is the electric flux, E is the electric field, ds is the area element, theta is the angle between the electric field vector and area vector, q is the charge enclosed in the closed surface, epsilon 0 is the absolute permittivity of the free space. You know very well, absolute permittivity of the free space value 8.854 into 10 to the power of minus 12 Coulomb square, Newton minus 1, meter minus 2. You know very well that one. Now let me come to this application. This is the Gauss theorem so far. Now I am going to take up the application. Let us see in the application. Let me explain with the drawing. Here, first let us consider infinitely long wire along the y-axis, V and V dash. Okay, in this V and V dash, in the V and V dash, you can see here along the axis is a positive charge. In this positive charge, now this long wire y dash is having a positive linear charge density lambda. Already we have learned that lambda and its unit and all those things. So I can say simply that it is having a positive charge. Now let us consider at point P, at somewhere distance point P, we'd like to find out the electric field. As it is a positive charge, you know very well electric field will be there like this. Now we are going to find out the magnitude of this electric field using the Gauss theorem. And Here also, this side also electric field will be like this everywhere on this. And you have to remember one thing, that electric field due to this surfaces, small surfaces, cross sectional area surfaces will not be there, because they are having a negligible area. Means in this direction, no electric field at all. Now, to find out the electric field, what we do is that we consider the Gaussian surface. What is Gaussian surface? Already we have seen. Gaussian surface is a surface where at each and every point on that surface, electric field is Cm. Now, I am considering here is a cylinder. That cylinder like this will be there. On this cylinder, each and every point, electric field will be the same. Right side, left side, up, down, everywhere. Every point, that is called Gauss theorem, the Gaussian surface. Now, the length of this Gaussian surface is L. The distance here is R. From here to here it is R. Therefore, this also R only, radius. So, we can say that cylinder is having a radius R, length L, I can say. I think you are able to understand this one up to this diagram. Briefly, I will explain this. Infinite long wire having a charge density lambda, I mean to say positive charge we are taking here. We are considering a point P here at a distance of R, where we would like to find out the electric field, and the direction of the electric field is E in this direction, and length of the Gaussian surface is L. Now we are considering the area here, this side area, small ds area we are considering. That ds area will be in this direction. Just you see that ds also will be there as per the definitions which you have seen. ds also will be there in this direction. I mean to say that electric field and ds will be the same direction. So here we can say that theta is 0. Theta between ds and electric field is 0, we can say. Okay. However, now we'll see the derivation using the Gas theorem. We'll see. Electric flux definition we know very well. Let us consider now the derivation I am starting. You see here. Now, electric flux phi is equal to electric field multiplied by the area of the curved surface, or simply we can say that curved surface area of Gaussian surface, cylindrical Gaussian surface. So, in this cylindrical Gaussian surface, let us see that phi is equal to electric field is E, curved surface. It is in the form of cylinder, you see. Radius of the cylinder is R, length is L. You know very well cylinder formula which you have learnt it in the lower class is 2 pi RL. I am writing here 2 pi RL. R stands for the radius of the cylindrical Gaussian surface. L is the length. I mean to say here height actually. Now E into 2 pi RL. This, let us consider this as a equation number 1. First one, this as a equation number 1. Now let us go to the next, this one, Gauss theorem. According to Gauss theorem, phi is equal to q by epsilon 0. So we are applying the Gauss theorem here. But you know very well, lambda is equal to q by L. In the beginning itself, we said that charge density lambda is applied here. Charge density lambda is there, aware. Okay. Now, q by L. From this equation, we can say that q is equal to lambda L. I think you understood this. Q is equal to lambda L. Let us substitute this q is equal to lambda L here. then what happens? Phi is equal to lambda L by epsilon 0. Lambda L by epsilon 0. See here, this one we have got it from the Gas theorem. This one we have got it from the figure. Let us consider this as a equation number 2. Okay. Now, left hand side flux. Here right hand sides will be equal. Then if you take it up, you will find out that E into 2 pi r L is equal to this equation lambda L by epsilon 0. See, first equation and second equation I am comparing. Phi LHS are equal, RHS will be equal, that you know very well. Now if you observe carefully, you will find that lambda L gets cancelled. E is equal to E into, this is, sorry, E multiplied by E into 2 pi r L, LL gets cancelled. Therefore, here, what is left here? E into 2 pi r is equal to lambda by epsilon 0. Our aim is to find out E. Therefore, you write it as E is equal to lambda by 2 pi r epsilon 0. See here, notes just I moved up. Once again I will explain. E into 2 pi r L is equal to lambda L by epsilon 0. E into 2 pi r is equal to lambda by epsilon 0. LL gets cancelled. Our aim is to find out E. Therefore, bring down this 2 pi r lambda by 2 pi r epsilon 0. Generally, we will indicate it like this. E is equal to, what we indicate is that 1 by 2 pi epsilon 0 lambda by r we indicate it. This is the final expression. This we call it as a scalar form. This will take it as a scalar form. Final expression. For numericals and all those things, we use that one. Now, E is equal to 1 by 2 pi epsilon 0 lambda by r. If you multiply it by unit vector r cap, sorry, n cap. N cap, see the diagram. N cap here is in this direction. N cap is in this direction, along the direction of the electric field. Right side. N cap it is. Then this will become vector. E bar is equal to 1 by 2 pi epsilon 0 lambda by r n cap. See the difference. E is now having cap with vector having unit vector n cap. N cap is now towards the right for this electric field point P. And one more point I have to tell you. Suppose if you take the point P here, it will go like this. And n will be in this direction. And one more point I have to tell you here. If this is a negative charge, electric field will be towards the wire. Means inward it will be there. N also will be there in this direction. That you have to remember. So depending on the charge, direction of the electric field will be there. Finally, this is a vector form. This is a scalar. First top one is a scalar form. This is a vector form. I think you have understood this. So, once again briefly I will explain Gauss theorem we are taking to find out electric field due to infinitely long straight wire. What we are doing? Infinitely long straight wire we are taking, which is having a linear charge density positive. Okay. Then at a point P, our aim is to find out electric field, and at a distance of r, point P is at a distance of r. Electric field is in this direction. Area vector we have taken, which is in this direction, ds. Now, this is a Gaussian surface, cylindrical form, which is having a radius r and height L. Now, first we calculated from the diagram electric flux is equal to phi into electric field multiplied by the curved surface of the cylindrical Gaussian surface. Phi is equal to E into 2 pi RL. According to Gauss theorem, now this part is over. Second part is according to Gauss theorem, phi is equal to Q by epsilon 0. But we know very well lambda is equal to Q by L. Therefore, Q is equal to lambda L, we can write it. If you substitute lambda L here, then it will become phi is equal to lambda L by epsilon 0. This is the first equation, this is the second equation. Left hand side is 5, left hand side is 5, right hand sides will be equal. So E into 2 pi r L is equal to lambda L by epsilon 0. LL gets cancelled. Then E into 2 pi r is equal to lambda by 0. Our aim is to find out E. E is equal to lambda by 2 pi r epsilon 0. The general form which we write it standard form in most of the books, it is written E into 1 by 2 pi epsilon 0 lambda by r, which is of the scalar form. In the vector form, what we do is that we will multiply by the unit vector n cap. For this diagram, n cap is in this direction. If it is a positive charge, it is like that. If it is a negative charge, it will be left side, it will be coming from the point P. So this is the first application of the Gauss theorem. Students, I think you are able to understand the first application. Next class, I will take up the second application. By the meantime, you go through this application, and in the YouTube comments, please give the feedback and suggestions any for the further improvement of the video lessons. Thank you very much for watching and attending the class. Thank you.